Let's do 2 again, just for quickly and for practice.
Okay.
It's pretty straightforward. This time we have first a much more complicated demand equation. Quantity demanded is 34 to 10. And this is for good Z, okay? This is a good in questions. Minus 5.02 times the price of Z. Now, normally, if you looked at just that, you'd say, oh, well, there's a demand equation. It's got an intercept, it's got a slope attached to the price of Z. Okay, so far? The coefficient in front of the price of Z is the system they use in the textbook. This would be called alpha Z. Alpha is the coefficient in front of that variable. So alpha Z is negative 5.02. I'm going to come back to that as we go along. Let's write out the rest of this equation. Plus 1.6 price of Y minus 1.2 price of R plus 0.22 N stands for income. So what is alpha Y? What is alpha Y in this equation?
1.6.
Positive 1.6. It's the coefficient to include its sign. So alpha Y is positive 1.6. Alpha R is a negative 1.2, and alpha M is positive 0.22. So when you see those alpha notations later in the textbook, you know what they're talking about. It's always cool to put those Greek letters up there. It confuses people who don't know what they're doing, so they can look pretty smart. And then when you learn how to say oligopolistic competition at a cocktail party, you have a couple of things like that you're just making notes on. You're cool.
You're cool.
Yeah. You could probably pick up some economist. Loser. Did the lights just do?
Yes.
Yeah.
Are we in New Orleans?
Yeah, right?
Don't make fun of my town. Come on. That was, I was watching it and I'm like, figures.
My first thought was, please God, don't let this be another disaster.
Yeah.
My second thought was, I bet the Chinese hacked into the electrical system.
Or Beyonce just took it something.
She took it all down. That's what I was thinking.
Yeah, I have to admit, I was not impressed.
Yeah.
But, I'm old. So. Okay, we got a basic equation here. We're going to plug in some numbers for some of these variables, and we're going to bring it down and reduce it to its basic format. QD of Z is sum intercept plus slope P. What numbers do they give us? Well, they say, look here. The price of Y is $450. The price of R is $125. And incomes are $40,000. So you go plug all those things in, and you're going to get something kind of like this. I'll draw all that. 34,210 minus 5.02 PZ plus 1.6 times 450. 720 minus 125 times 1.6 is 150. And 44,000 times 422 is 8,800. Okay so far?
Yeah, the one thing I thought maybe I did is like when the price, I know what I did. The PZ, I plugged in another number.
Yeah.
Okay.
Okay. So this is just still got the price of Z for it. So let's sum all this up. Take the 34,210 plus 720 minus 150 plus 8,800 and see what you get. I get 43,580 minus 5.02 PZ. And there, by golly, is the basic demand equation the way we're used to seeing it. So just plugging in those numbers and plug and chug and sum it up, no big deal. We okay so far? Okay. What will sales be if the price of Z is at $6,100? Well, it's pretty simple. You just plug it in there and subtract. So I got something along the lines of QD is 12,958 units at a price of Z equal to $6,100. Okay? What's the slope of the demand equation?
I think you're at 5.02.
Negative 5.02. Alpha Z is in fact the slope.
Because in front of the-
So we know the slope is negative 5.02. Okay, I'm going to draw a picture here in a minute, so I'm going to have to erase all this stuff. Let me know when I can do that.
I'm sorry, so 43,580 minus 5.02 times
TZ,
PZ,
Yeah, which is 6,100.
Z.
which is 6,100.
And when PZ is 6,100, then you are selling 12,958 units.
Okay, so PZ is 6,100. Hold on, I'm just going to.
Okay, so far? Can I erase this yet? Not yet?
No, not yet.
Okay.
I'm sorry, I'm going to have to get back. Okay.
Okay. Do you think you could draw this demand curve graphically, visually? You have the two pieces of data you need. You don't have two data points, do you? You only have one data point, but you also have the slope. So that's what I want to do. Here's going to be the graph, more or less. And we know one point. At a price of $6,100, the company sells 12,958 units. So there's point A. We know that. We know there's a demand curve going through it, and we happen to know the slope. Okay? I'm just going to approximate something here. Let's say that it looks kind of like this. I want to find out how much consumer surplus there is at that price. So what do I need to do?
You need to find the P-intercept.
I need to find the P-intercept, the price intercept up here. Right there. How will I do that?
Take quantity
Change.
back to zero.
I'm going to reduce the quantity back to zero, exactly. So what do I know? I know the slope is equal to the change in quantity over the change in price. I know the slope is negative 5.02. I know my quantity has got to decrease by 12,958. So I can solve for the change in price. Continue over here. The change in price is 12,958 divided by minus 5.2. I'm going to approximate this, a little rounding off. 2581 positive. Okay so far? So I know the distance here is 2581.
I have a quick question.
Yeah.
On the test, you want us to round up
or round down, or it doesn't matter?
Either way. I want you to show me every step of your work, and as long as your procedure's good, you're going. So I know the intercept up here is, I don't know, 86.81. That's my price intercept. Can you tell me how much consumer surplus there is in this model?
16,722,299.
15 or 16?
16.
16. Mhm. And you did that in your head too. That's amazing. You know, consumer surplus is the area of this triangle. You know that it follows that pattern, so there's 1/2. The base is 12,958. The height is 2581. And so consumer surplus, right over here, consumer surplus. 16,722,209.
That's when I always think I'm wrong, when I get this big number.
Say again?
When I get a big number like that, I think I'm wrong, because it's so big.
That's absolutely natural. And particularly when Strickland's making up numbers.
That's why I'm a little scared at these ones that don't have answers. I'm like, yeah, it just seems so big, and I'm like,
Well, see, and that's why to me, the next step is to calculate the total revenue and see how they're doing. What's their total revenue at 6,100? That would be the area of this rectangle I'm shading in here.
Price times quantity.
Price times quantity. So total revenue will be a really big ugly.
79,043,800.
$79,043,800 total revenue. How are we doing so far? What's total value received?
95,766,099.
95 million.
766.
766.
099.
099. Okay, so far? We need to come up with a name for this, and I don't know that there is one.
Clustery.
sorry.
It says with their outside list.
What is the performance ranking, if you will, or performance ratio? Let's call it for now the performance ratio, which is your total revenue as a percentage of your total value received. So you want to be about 18, 19%? Anybody got this work?
I have 0.825.
No. It's, oh, okay, 79, yeah, you're probably right. 0.825?
Yeah.
Okay. You're capturing 82% of the value out there. So that's not too bad. If you had a performance rating of something like 0.27,
That'd be bad.
Yeah.
you
Another
know
Good
that,
about
another
business
line.
at work.
Somebody needs to be.
Somebody's messing up.
think of it a little bit deeper. You know there's a lot of people out there willing to pay a lot more money. And so now you start asking, who are they? What are their characteristics? Are they of a particular income class? Do they come from a particular part of town? Do they listen to particular radio stations? And then you start your marketing, your target marketing towards those groups.
That's probably when they start doing that survey to try to figure out.
You bet.
The purpose of, the consumer preferences and
Yes,
stuff like that. So
exactly. So we
reposition
begin to
themselves.
open up the idea of so much more about business just when we realize how much money's walking out the door. Okay?